All right, y'all, welcome back. We are once again going to be doing some more review practice, and this time we're going to be reviewing naming ionic bonds with transition metals. All right, let's get started. So we've got our periodic table here, and let me get my pointer again. So here are our transition metals. Transition metals are in the middle of the periodic table, but I've only highlighted the ones that we're really going to be using in this class because we're never going to use like technetium or rhodium or osmium. We're not going to use those, but these are primarily what we're going to be using in this class. And then once again, here are the non-metals as a little review. And one thing to remember is I didn't write this on here, but an ionic bond, as we've watched in the last video, is a metal and a non-metal, which is why I put the transition metals and the non-metals, because that's what ionic bonds are made up of. Anyway, here's the thing about transition metals. Transition metals are different. Remember, transition metals can have multiple cation charges on them. So they're not only +1, like sodium is only +1 and like chlorine is only -1. Transition metals can have multiple charges on them. And that's just the nature of transition metals. They're different. So for example, I've got Fe +2, iron +2, iron +3, copper +1, copper +2. So that's just something to know. So the way that we tell the charges on these, because they can have different charges, is we use Roman numerals. So iron Roman numeral 2, we call that iron 2, is for iron 2+, and nickel 3 is for nickel 3+. I mean, that makes sense, y'all, you know? But that's why we use the Roman numerals, is that way we know, oh, I'm talking about iron 2+. I'm not talking about iron 3+. So we got to use the Roman numerals. So let's do an example. Here I've got silver and oxygen, and this is the compounds that it makes. So let's go back to our periodic table. Here's silver. It is a transition metal. And here's oxygen. It is a nonmetal. So that's an ionic compound using a transition metal. So what is the charge of our transition metal? Well, that's simple. It's right here. So it's going to be +1. So if the charge is +1, what would our Roman numeral be? 1. That's it. So what would its name be? Its name in English. Once again, we got to write out those Roman numerals because we got to know which type of silver are we talking about. So its name would be silver 1 oxide instead of just silver oxide. We don't write just silver oxide, or yeah, because silver could be +1 or +2, you know? And silver 1 oxide and silver 2 oxide is very, very different. They are very different compounds. So knowing this, what's its formula going to be? Remember from the last video, we did the crisscross. So we've got 1 here and 2 over here. Do the crisscross, silver with 2 of them and 1 oxygen. And that's called silver 1 oxide. That's what we call it. All right, let's do one more example. So once again, we got our transition metals, we got our non-metals. All right, so now we've got this element and this element. So let's go back to our periodic table and see what they are. So Cu, that's copper, and that's right there, and that's the transition metal. And then Cl is chlorine, which is a non-metal. By now, y'all should kind of know like where chlorine, bromine, iodine, iodine, nah, that's not how you pronounce it. Y'all should like kind of be noticing where they are, but I like to color code them for you just to help you out. So anyway, the charge of our transition metal in this case is going to be +2. Bam. So we've got a +2 on copper in this case. Copper can usually be +2 or +3, sometimes +1. You know, it can be all of those. So the Roman numeral in this case is going to be 2. Makes sense, right? So its name is going to be copper 2 chloride. And remember, don't just say copper chloride, because it could be copper 1 chloride or copper 2 chloride or copper 3 chloride. Those Roman numerals will haunt you. If they don't haunt you, you got to let them haunt you. You got to remember those Roman numerals. So its formula, crisscross. This one's pretty simple. It's going to be CuCl2. Once again, no prefixes, and that's it. So copper and 2 chlorines, doing the crisscross. All right,